We're going to solve this simultaneous equation using an elimination method. I'll label both of the equations so that you know what we're referring to. Equation number 1 I'm going to keep the same. But equation number 2 I'm going to multiply by 3. This means that I have the coefficients of x in both equations equal. I can now subtract these two equations. This gives me 14y equals minus 42. And then dividing 3 by 14 gives me a value of y of minus 3. I now substitute this value of y into either of the equations. I'll actually substitute it into equation number 2 because it will make it a little bit more simple for me. And it will give me a value of x of 2. If I was in an exam and I had time, I would check this by substituting both values back into equation 1. We're now going to solve these. I'll label both of the equations again. I need to ensure that I get the coefficients of either x or y to be numerically the same, or at least of the same magnitude but of different signs. I'll multiply equation number 1 by 2 and call this equation number 3. And I'll multiply equation number 2 by 3 and I'll call this equation number 4. And now we can see that the coefficients of y are the same. I can now subtract one from the other to eliminate the variable y. We'll now get a value of x as 8/11. Substituting this value of x into equation number 1 enables me to find the value of y. Multiplying out the bracket and giving everything a common denominator of 11. You could of course just multiply through by 11 here. Now since the denominator is the same, the numerators must be the same. And so we have 33y equals 39. And dividing through by 33 gives a value of y as 39 over 33, which of course can be simplified. The alternative method of solving simultaneous equations is the substitution method. I will still label the equations 1 and 2 so that I can refer to them during my working. And from equation number 2 I can rearrange it to get an expression for x of x equals 11 plus 3y. I'll then substitute this into equation number 1. I now have an equation with just one variable. Collecting like terms gives me 14y equals minus 42, and then dividing through by 14 gives me y as minus 3. Now I have an expression for x of 11 plus 3y, so substituting the value of y into this expression gives me a value of x of 2. We also need to be able to solve simultaneous equations involving the quadratic. Note I will always use an elimination method here, and I will always take the equation which is linear and use that to substitute into the quadratic expression. So we can write x is equal to 3 minus 2y, and I can substitute that into equation number 2. And multiplying the bracket out here, and collecting like terms so that I now have a quadratic equation in y which I need to solve. I'll solve this by factorising. I'll go into two brackets, and now I can clearly see two values of y is equal to 3/5 or y is equal to 1. I now need to consider both of these cases. So if y is equal to 3/5, I can substitute this value of y into equation number 1. And multiplying out the bracket and multiplying through by 5. So I now get a value of x of 9/5. Or if if y is equal to 1, we then get x plus 2 equals 3, and therefore x is equal to 1.